So the test will be posted at 1 o'clock. And we'll stay here a couple of hours. If you want me to stay longer, I can do that. But usually students like to just go and get themselves organized for the test. But let's see how it goes. I'm recording, and so I've been recording participation. If anybody's confused about the participation scores I have up, that's for participation for 4 points of interaction and answering questions, asking questions. And I have a record because I have the video and I have the transcript from the chat. And then I always give 1 point. So 4 points for participation, activity, questions and answers. And then I have 1 point for having your camera on. So just having your camera on gets you a point. I understand sometimes it doesn't work, or you don't want to put it on, and I understand, or you're in the middle of something else. But I prefer to reward you for focus. So it's a double reward because you're going to learn better and you're going to get your points. Okay, so I'm going to ask you, yes, any questions?
Professor,
Yeah.
I didn't get the information regarding the assumptions that are discussed in page 11.
Oh, you didn't understand that?
Yeah, can you talk about that?
Okay. I won't test you on that.
Okay, perfect.
But if you want to know, I can talk about it.
I have no doubts then.
That's good.
Yeah, I kind of know where to stop because that opens up a lot. Unfortunately, it's really important to know the assumptions because that's where the second course in statistics or regression comes, to talk about violation of the assumptions, adjustments of the assumptions.
Okay.
But I do not have time in this course to do all of that. But there should be a course in regression in the program, and maybe I'll build it one day. But yeah, so that I just leave it there for people who have some prior knowledge and they want to see the continuity, you know, where it fits with what they've learned before, because I teach a very basic version, and I want to be able to say, well, then we can add another variable, and that's kind of the starting point for that. Because really multivariate analysis or multiple regression is really what people do. You know, people don't just do simple regression. And it's important to understand the theory and the assumptions and how you build models. But yeah, we don't have enough time to do it. And it is confusing.
Yeah.
Mm-hmm.
So my doubt is already dissipated.
Okay, good, good.
I have one on page 6 about the equation of a line, and how to point the slope, or define the slope in the lines.
Okay. Okay. Okay, hold on. Let me pull up the document. So we're talking about regression module 5.
Yeah. Page 6.
I had the same doubt.
Oh, okay, making a line. Okay, making a line. So did you watch the video, or
yeah
still want more? Okay, it's okay. Yeah. It's okay as long as you did watch it. That gives me a starting point. Okay. So this is the I'm gonna share. Let me know if I sound far away, because I'm just speaking right into the computer right now. All right, that's it, right?
Yeah.
Yep.
Okay, so there's different ways to draw a line. And I focus on one method just because then it's the method that we use to interpret the least squares regression line. and also to derive it. So to derive and interpret. So I'm going to focus on that method. And I begin by reviewing lines the way that you did, or, you may have, or based on what you did before, you could understand how I'm going to draw the line. So remembering the equation of the line, which is either y, hold on. How many of you saw this equation of lines when you learned lines in high school?
Yes.
Did any of you see this one? No. So the first is more familiar?
Yep.
The first one, yes.
Yeah. Okay, but we're going to appeal to this one, but we're going to do it this way, just because this is alphabetical order. So statistics uses a lot of alphabetical order for instruction and for organization. So it's going to be A, B, and then I can add another variable, C, D, E, and that's what happens. So that's how the model goes. So what changes then is we're going to call this one. Well, let's do this. Let's do this. So if X is 0, what is Y? This is in general. If X is 0, so you put a 0 there, 0 times B is 0, so Y is A. Right? So this is the idea of the Y. This is the Y-intercept. It means literally when X is 0, Y is A. So X is always here, horizontal. And Y is here. So when X is in 0, this is 0 here, it's negative there, and it goes positive that way. So when X is 0, Y is up here. So it's where it crosses the Y axis. So it also gives you a point if I plot it. So it gives you a point on the line. And if you have any point on the line, you can find the next point on the line by using the slope. The slope brings you back to the line. It's the rule for the relationship between all the points on the line. So it is sometimes we say rise over run. Do you use a different language in English? I mean Spanish. So this is the way it works, right? So the B here, you would have learned about M, the slope, but now we use B. And we interpret it if we leave the line, put a 1 under here. If we move away from the line by 1 unit, to get back on the line, we have to move B units in the Y direction. So if we leave the line in the horizontal direction by 1 unit, we can return to the line by using B units. So for instance, let's take the first one. So from the first one, I can get the slope, sorry, the intercept. I'm going to use blue. So the first line, A is what?
3.
3. So I can draw that. So then, so 3, 0 is on the line. So I can draw that. Everybody's okay with that because I just think about this. Oops. When X is 0, Y is 3. So that's how I figured that out. And I wrote it wrong here, sorry. I wrote it backwards here. So when X is 0, Y is 3. That's the point. So then I start here, X is 0, and I count. I'll make just some marks here. So when X is 0, Y is 3. 1, 2, 3, and I mark a point. It's too small. All right. So that's my first point on the line. So the intercept gives me a point on the line. And then from here, I can leave the line. Using the slope, I can get back on the line. What is the slope?
Is 0.5.
0.5 or 1 over 2. So this says I can treat that as the relationship between the points, and I can leave by 2, and to get back on the line, I go 1, and that gives another point.
Can you repeat that, please?
Yeah.
Okay. So I begin at 1 point on the line, so that's here.
Mm-hmm.
And
Okay.
then this says, for every 2 points in the horizontal direction,
You go 1 up.
go 1 up.
Mm.
Okay. So if I go 2 in this direction, I go 1 up, and that's another point on the line.
Oh, now I get it.
Yeah.
It's starting on the A.
Starting on 1 point, and that's the one, that's the easiest one we know. So yes, starting on the A. And then I can make my line. So I can join those. Oops. There was a ruler here, but I always get distracted with it. Let's see if I can. This helps me make my line straight. Okay, so that is line 1. Now let's talk about the slope a little bit more. If I move, so this is a relationship. This is the proportional relationship. It's saying for every 2 units of X, you get, so sorry, for every two units change in X, you're going to have to adjust with 1 unit change in Y. So that's same if, what if I change by 10 units in X? No, that's too big. Let's do 5. Or let's do 0. Let's do 1. Sorry, let's do 1 unit. So if I have 1 unit change in X, how much should I move Y to get back on the line?
1.
If I move X 1, so this is what Orlando said at the beginning, this is 0.5. Okay, so it's 1/2, 0.5. These are the same relationship. Okay, also if X is 5, what is Y?
You move 2.5 on Y.
Move this here. Yes, very good. So if change in X is 5, I said, then you have to, then it's half, right? So 2.5. So you can see it. If I move 5, and if you've drawn this to scale, 1, 2, 3, 4, 5, and then, sorry, not here. If I go here, 1, 2, 3, 4, 5, to get back, I got to go 1, 2, and a little bit more to get back.
So that is your prediction.
No, this is not a prediction. This is a mathematical line. So this is, so I begin explaining mathematical lines because we learned it. We explain mathematical lines because we learned it in the past, so I want to start there. But then we talk about prediction lines, and you use the same sort of interpretation in the range of values of the observed values. But yes, that's how you use the line. Okay, so just like I can draw the line if I know, if I can extract A, which gives me a point, and then using the slope, I can get a second point on the line. The other way to do it is to just plug in values, right? I could plug in values and get 2 points on the line. But I'm trying to make you maneuver as we will when we talk about the prediction line, like someone just mentioned. Sorry, I didn't see who it was. Was it Christina? Okay, thank you. All right, so you want to try the next one yourself and then I'll draw it? Oh, so there's, okay, I'm reading the problems. Yeah, put them in the chat and we can look at them. So that's good. You guys got to the review exercises. That makes me happy. Good. I got mine working. A little bit blurry. I don't know. I'm not sure what's wrong. I don't want to touch anything right now, so I'll work on it after. You guys are a little, you guys' cameras, but yours better than mine. Doesn't make sense. All right. So you're trying number 2. Same technique. The hardest part is making the scale evenly. It's nice to have a few pieces of graph paper. If you don't have a sheet of graph paper, what you can do is you can just print them. Online they have graph paper, and you can just print a page and it's all lined for you. You don't have to buy a whole graph paper book. You know what I'm saying? With Quadrada, right? With, yeah. Okay, so I'll start mine. Looking here. for L2, I make my calculations here. So when X is 0, Y is 1/2. So the point 0, 1/2 is on the line. In other words, A is equal to 1/2.
Isn't -3, Professor?
Mm. No, if X is 0, as you see, that makes this 0, and then Y is 1/2, because it's 3 times 0.
Ah, sorry, I forgot. I got confused with the
It's
the
okay,
slope.
because it's yeah, because you used to this one with the half over there.
Mhm.
Yeah.
I have a question.
Mm-hmm.
We always start assigning 0 to X. And then
That will just help you find A. If you can just see it's A, that's
Yeah.
fine. You don't have to put this. You
okay,
can just say that's A. I'm just defending what it means. So it's a Y, it gives you a point and it's a Y intercept.
B is the one that is -3.
Exactly. And then B is equal to -3, or you can write -3 over 1.
Over 1.
Remember that we begin changing X with a positive 1, and then Y must go down 3. So I'm going to draw the first point. So we're going to start at the first point, which is 0, 1/2, which makes it tight, but I will put it there. And then from here, if I move over 1, I'm going to make this a bit bigger so we can follow. So if I move over 1, then I have to go down 3. 1, 2, 3. Get it? So if I move over 1, I have to go -3. 1, 2, 3, and I draw a dot there. I have to make it big.
Professor, but the point is in the X axis, or is it supposed to be in the intercept
Oh my
in the Y?
goodness. Thank you for stopping me. I did it. Yes, sorry, I wasted time there. Yes, I'm so preoccupied with my bad scale. Let me fix that first because it's distracting me. So 1, 2, 3, let's do it again. So we begin with the y-intercept, apologies, at 1/2, -1/2.
But Y is negative.
Yeah,
Oh, sorry, it was positive. Yeah, it was positive.
okay.
And then from here, we move over 1 on Y, on X, sorry, and then up 3, down 3. So we move over 1 on X and then down 3. And so down 3 is going to be -0.5, -1.5, and then -2.5 here.
Mm.
And I
And
put
always
here.
the change is always to the left, to the right, right?
Okay, so hold on, let me finish and then I'll talk about it.
I have a question.
One moment. Oh, right. Hopefully I did that right. Okay, let me recap and then you can ask your question. So A is 1/2, so I start at 0, 1/2. And then I use the slope to get to the next point to make another dot. So I start here just because it's my habit to start here. But I could have started here, but I usually like the interpretation. I move over 1 in the X direction. And then I use the change in Y to get back on the line. So it's going to be 1. So from, oh, it's acting funny. So then 1, 2, 3 is my third dot, and I join the points. And I could have gone over by 2, 1, 2, and then I would have to go down 6, right? 1, 2, 3, 4, 5, 6, something like that. And then that would also get me back on the line. Again, it's all dependent on the scale, keeping this at scale. I gotta turn that off.
I have a question here.
Okay, question.
Okay, because I thought I heard you say 2.5, and when you were moving down,
Because I'm working at a half, so I'm going 1, so I'm counting on the scale, so it's
Oh, okay.
half, 2.5, 3.5. That's why I'm counting half. I'm not counting, I'm going by ones, but it's putting me halfway on each unit.
okay.
Sorry,
Oh,
lots of numbers floating around here, but I'm going,
So 3 spaces down.
so
and if
3
it-
down, 1, 2,
Mm.
3.
Okay.
From here, because I start here, so 1, 2, and 3. And that goes on forever. That line extends both directions. Should I let you try the last one? Try one
Yes.
more?
Yeah.
So the video was not helpful, or you just got stuck right at the beginning?
I got stuck at the
Yeah,
beginning.
at the beginning.
Okay. It's all right. I'm glad that you asked me, because it really, I like students to feel like they're not learning something new exactly. They're adding on to prior knowledge. That's why I appeal to your high school mathematics. But I did twist it because maybe you didn't learn it like this, or you didn't draw it like this. But that's the best way. It's a comprehensive way to draw the line. That you understand the slope is the relationship between all the points.
Professor,
That's why it gives you the whole an infinite line.
I have a question. If for example, I learned it through another way in the test, is it okay if I do it my way and obtain the same results?
Well, I'm never going to ask you to draw a line. This is just to show you what A and B are, and then we derive A and we derive B and we make the interpretation of a line. So it's just to get you to know A and B, really.
Okay,
So you
perfect.
can
Thank
do
you.
it another way, but as long as you know what A and B are.
Perfect. Thank you.
So then I have this question down here. Find the equation of a line with slope of 1.5 and 0.2 -1, because that's what we're going to do. Well, you guys can draw this one and then we can talk about that. So given the equation of a line, draw it. And then given information about the line, a point and a slope, you should also be able to make the equation of a line and draw it. Like describe the equation of a line. So right now, yeah, just do V3, line 3 first. So for line 3, A equals 2, and B equals negative 5.5, you could say over 1. So A is 2, it means that when X is 0, Y is 2. So I can plot the first point at 2. And then from here, move over 1, and then I have to go down 5.5. 1, 2, 3, 4, 5.5. So it's going to be very tight with the other one. Or I could go 11. Right, that will be the same. I have to mark here. Like there. So I go over 2, but then down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, like here. That'll also put me on the same line. I did it with 2 rather than 1. You get the point. I'm not gonna draw, it's just gonna be so close, blur everything, but you guys get the idea?
Yes. Thank you.
Yes.
Should have made my grid so much bigger. Okay, I'll just try this again. It's just confusing because I have to adjust everything to do it. All right, so let's get rid of this guy. And then we'll be here. With the red line. And that's going to be line 3. All right. And the last one, the last question here. Yeah, I think I blew this because I needed a larger scale. And I forgot. So I have so many here. Find the equation of a line given a slope of 1.5 and a point of 2, -1. So this is what we're going to do, where we're going to calculate what the slope is. We're going to estimate the slope given data, and we're going to estimate the y-intercept, or here's a point given to you, so you use this one, and then make the equation of a line, knowing the equation of a line is y equals a plus bx. I can use the point 2, -1, so this is the x, and this is the y. It's just one point that satisfies this equation. So this is -1, this is a plus, and you're told b is 1.5 and x is 2, so you can solve for a. This is 3 equals -1, so a is -4. So you have a, you have b. So given a point, you can find the intercept and use the slope to make the equation like we've been doing, or like we've been using. So the answer is y equals a, which is -4, plus 1.5x. And this is the mathematical line. It's the relationships between all the points in the XY coordinate space infinitely. And then we repeat this where I tell you that every scatter of points, with every scatter of points, you can find a least squares regression line that passes through the point that's closest to all the points in the horizontal direction and closest to all the points in the vertical direction. And that point is x bar, y bar. With that point, and then you have to calculate the slope. And I show you a calculation so you can get the slope very quickly. And that comes out of optimization theory. So you actually would have to, to understand that derivation, it does actually apply calculus. So because calculus is not necessary for this course, I just give you the result. Okay, so that result is derived from calculus. Oh, this is not a good drawing for me. That this will fall in the line because it's closest to all the points. This one is the way, this is how you calculate the slope. And I mean, you don't have to memorize it, but it's good to have a mnemonic device just to double check you've copied it properly or you've applied it properly. And I use the mnemonic risk R times SY divided by SX to remember this. But you can derive this mathematically, but it's outside the scope of this class to do it. But it does show you something, if you take a moment to look at it, is that there is a relationship, the slope comes from the correlation coefficient. The correlation coefficient R is a measure of the direction and strength of a linear relationship between two quantitative variables. So since SY, the standard deviation of the response variable, and the standard deviation of the explanatory variable, since those, and it matters the order, okay, you have to use the Y on top. These will always be positive. How do I know these will always be positive? Because what is...
Porque,
Mhm,
porque se saca el cuadrado.
exactly. Because the standard deviation is the square root, and the square root would always give a positive. So these will be positive, which means if the correlation between the variables, so that the trend is positive, then the slope will be positive. If the trend is negative, the slope will be negative. They are related like that. So I'm not sure how far you guys got in your review, but so essentially you're going to use this calculation to get the slope. If you have some gaps, you can go back and learn, but basically we're going to repeat what we just did, but in statistics, this line is a prediction line. This line is a prediction line. It means that it only applies to a certain portion of the coordinate space, only where the values have appeared. Outside of those values, you shouldn't extend this line. So over here, these lines extend. This line extends all the way out. This line extends all the way out. I don't draw it all because I have other things to do with my time, but this is understood. This goes all the way out. But in statistics, we put a hat to remember this is a prediction line. These are actually predictions based on a sample, right?
Mm-hmm.
And so I actually put hats on there, but it just looks so busy that I think statisticians don't put it. But these are all predictions of the line. The line is called the least squares prediction line, or the regression line. And it's the line that fits closest to all the points. And that's done in such a way that it minimizes the sum of the squared residuals. And I explain all of that in the video. Watch that video because really what I want you to do is carry out the operation. So watch the background of where this comes from. And then, so once we have the slope calculated, we have a point, we can make the line, just like I did just now.
Mm.
So this will, in this data set for the fossil specimens, we had this as the mean of X, and this is a mean of Y. So this must fall on the line because the mean is closest to all the points. It sits in the middle. Remember, it's the balancing point of the data. So on both sides, it is closest to all the points is another way to think about that, or to all the values. It's the shortest distance. If you're at the mean, you can get to, it's the best place to be able to get to all the other locations in the quickest way, or the shortest route. And the same with Y. Maybe you've never heard that interpretation before, but that's the idea of the center of gravity, or the balancing point. And the same for the Y, the values in the vertical direction, or the Y variable. So I can calculate a slope using this calculation, this formula, and then just plug it in as I did. I put in the values that I have. I put my Y in there, I put the X in there, I put the B in there, and I solve for A. Now, you could do this with less decimal places. In general, in my notes, I explain that I keep 2 more decimal places than the actual values, but this is getting unruly. So I start like cutting down, but even here, it'd probably be better to cut some decimal places. I also show you how to do this in Excel. And that's another route. But I prefer you to write for this test. You're going to write everything out. I don't want you to, well, you can check everything in Excel, but don't send me any Excel. Okay. You can check all your answers for normal distribution. You can check your answers for the regression lines. You can check everything in Excel the way I demonstrated in the videos.
I have a question.
Yes.
I entered all of the data on the calculator, because you have X and Y, and
Where
gives
here in number 3?
no, to do the
Oh, to do it on the calculator.
right.
Okay, yeah. Okay.
So
That's another thing I taught you. Yeah.
I only get the numbers. I mean, I don't.
Okay, let's do that.
Want me to write just the results?
But you did it for this? Oh, you're saying if you solve a problem in your calculator, and get the,
Because if you go down, it gives you
los 2 lugares decimales nada más.
no, it gives you the standard deviation, and it gives you everything.
yeah, if you use that calculator, you get the result. You also get the
entering
result,
that?
but your question is how do you put that on the test?
Right.
So you can, okay, so this is the thing I'm going to tell you. The only way you can go wrong with this is if you mix up X and Y, because it's not hard, right? It's not hard. If you mix up which one is X and which one is Y, so you have to be clear which one is X and which one is Y. And to provide evidence, I'm giving you guys a lot of time so you can provide evidence of what you're doing. If you can just put these 3 steps down, that would be best. If you don't put anything on your exam, it's going to be difficult for me to know what you did. Right? Because you're just going to put them in and then you're going to pick the wrong answer if you did it wrong, and then I'm not going to have anything to see in case I want to give you mercy points.
So
I
Professor-
prefer that you write 1, 2, 3 and solve the parts.
So
Okay.
even we do everything through the calculator and in paper, we cannot just put the last answer and that's it, right?
You could just write down, I use my calculator. You can give me some information, but I guess this would be, so like if I asked you to calculate the standard deviation, I don't expect you to do the table. If I ask you to calculate the correlation, I don't expect you to do the table. But for the regression line, I think I can ask you for this. This is not so bad, is it? And that way you can confirm what you did. But yeah, I don't, for the standard deviation, I don't expect you to do it manually. That's a waste of time. Because I taught you on the calculator. So yeah, the calculator is great. Anybody have questions about how to enter in the calculator? Because I do explain it. So you put it into data, and then you go for all the statistics, and that's the linear regression results, and it will give you the mean, the standard deviation of X, and then this number, we already discussed, that's not appropriate. That's only if we have all of the data and we interpret that as the population standard deviation. Then we have the sample mean, the sample standard deviation, and then the population, then that would be A, B, and R for whatever numbers I had in here.
When I was doing this, it didn't give me A and B,
Oh, really?
yeah,
Keep scrolling down.
because it gave me an error. I mean, I got the numbers correctly for the what we were doing in the.
You entered them correctly?
Yeah. And I was able to change them if I made a mistake and look for it.
Good.
Pero I kept going down. I was looking for an R here.
You didn't get R. You should get R.
I'll try it again.
So second stat, okay, let's see if you get the same as me. So Lynn, then N, then X bar. Are you going with me? These are the wrong answers. This is another problem, but just to show you what you should be displaying.
Lynn,
SX.
I think I erased everything.
Oh, really?
Yeah, I mean, I did it on purpose because I wanted to know how to erase the information.
Yeah. So, okay. So then if you want to erase, you have to go data and then second clear work, and that clears everything. Yep.
I'll try it again. I don't want to.
Okay, try it again, and I'll see the other problems people have. Does anyone want to see the calculator? I mean, it's in the video, right, Christina?
I just started entering and then I realized there's the what, so let's put the information there.
Yeah, I'm pretty sure I explained it in the video because I did even in a class prior. Am I wrong?
Professor, I have the same after the B, I just have an error on the calculator.
Okay, well, let's see. Let me enter it with you then. Let me go back and get the data set. So for this one or for a different problem, for another problem, for these numbers?
Yeah,
I have it here for other programs that is not for this one, but still I just have the SX, the number that we never use. Yep. Then then the Y and then the A and then the B, and then I have an error. I don't know.
Okay, so just to review, I'm going to plot Y versus X. Whenever I say it like this, that's how you know which one is Y and which one is X. Humerus versus femur. So femur is X and humerus is Y.
But I believe it's a formatting, maybe it's not like I have all the other answers correctly. I don't know if I
it shouldn't give you an error.
The what?
I've never seen that. I never seen.
Oh.
Mm-hmm.
I don't know if you can, nope, there, but anyway, it's error 1 or something like that.
I have the same problem. It gives me error 1.
Mm-hmm. It's after the B. So that's my point. I mean, I don't have the numbers yet in my computer, but with other exercises, I have all the results correctly, like meaning the average, everything correctly. But after the B, I don't have any other option of answers.
Okay, I'm going to step through it with you, okay?
Mhm.
Oh, wait, I got the A and the B and the R.
Good.
Got it.
You got it?
Yes, I did.
How?
I don't know. I just started. No, I went with the la flecha hacia abajo and it gives you the stuff.
Pero después de la B puedes seguir dándole a la flecha.
Sí, sí.
¿Cómo?
Start from the beginning. I did it now.
So let's clear clear everything. Something's in there. Something is in there. Gremlin is in there. So if I put in this one as X and this as Y, second data. So I cleared. I go into data and then second clear work to clear whatever was there before. And then start entering. X is 38. Enter down, Y is 41, enter down. I'm in the second pair. 56, enter down, 63, enter down. On the third pair, 59, enter down, 70, enter down, 64, enter down, 70, 72, enter down, 74, enter down, and 84, enter down. I'll just review my numbers.
The other thing that happened was that I got in the standard deviation 13.20 instead of 13.19. I don't know if that would be a
Yeah, so
problem.
it's just going to be a decimals thing. It's
Okay.
going to be a matter of the decimals, because remember I calculated these with the table. So that's going to be a little bit off. So, okay, so there's 5 observations, 58.2,
Mhm.
and then 13.19 is the standard deviation, which is here, SX.
Oh, no.
So this, I rounded, right? So in the calculator, it's 1.98. It's a higher number, but I had to round to make it, less crazy. But that's why it's going to be a little bit different. And then I don't use that number. So Y is 66. That's the mean of Y. Standard deviation of Y is 15.89. Then they give me A, which is just a little bit different because again, all those decimals affect it, okay? So that's going to be different. My answers, usually, I don't know why,
So
usually it shouldn't be an issue. You should be able to find the answer, with your calculator, or I think you should be able to find your answer with your calculator. I never had issues with this before, and the answer keys, like the clave, the numbers are very basic or simple. Everything falls simply. But see, the numbers are a little bit off just because I keep rounding. I rounded, and the calculator doesn't. It uses all the decimals. And then R is that. So I don't know what your error is, but try that.
no, yeah, I try it and I fix it, so I don't know how.
I don't know. It
Yep.
could have had a stray number from some other exercise you did or we did.
And another thing is I format my calculator to 4 digitals, to 4 decimals numbers.
Uh-huh.
So I don't
So-
know if that
Yeah, that's gonna confuse you too. So yeah, so just make sure you, second format,
Yeah, I already do.
okay.
But just to clarify, of course, that the roundel could change the numbers, right? Because
The decimals will change the numbers,
mhm,
but usually, using your calculator, you should be able to get the answers.
yeah, I
It's
get it.
fine.
Mhm.
Also, make sure your calculator, so this is for 9 decimals. And then for AOS, which is order of operations, I showed you that you hit second, it's second format, and you scroll down till you see, if you don't see AOS after scrolling down 1, 2, 3, so yeah, 4 times, 1, 2, 3, 4. If you don't see AOS, then you need to convert it to order of operations. So you hit second set. So you would have seen CHN, but make it AOS. And that will also facilitate your calculations because it honors order of operations. Save you a lot of trouble. Okay, let's get into the midterms. Okay, so midterm exam review 2. So I'm going to go in order in the chat. Is that okay? Jaime or Jamie, is that on the review 2? Or review
No, in
1?
the midterm,
Which one?
the first one.
Put that in the chat.
Okay.
Okay, so I'm gonna start with let me download them to my iPad. So I'm going to start in review 2. And number 6. The standard deviation of the ages in a family of 4 is 15 years. What will be the standard deviation of the ages in the family 10 years from now, assuming the composition of family remains the same? Okay, so yeah, what is the concept of standard deviation? What is a standard deviation? What's the definition, or how do I refer to it?
Deviation from the mean.
Right, so it's the average. It's like a measure of the average okay, so variance is equal to the average of the squared deviations from the mean. The average of squared deviations from the mean, and then you take the square root, right? So the deviations from the mean, it's all depending on the deviations from the mean. Is the deviation from the mean going to change as people get older? Like, are you always the same difference in age from your brother?
Yes.
Yeah. So that's the essence here. It's not going to change as you age. It should still be 15. Is that okay, Carolina? So you say, oh, my brother's 5 years older than me. It's the deviation. It's the same.
Yeah, thank you.
Okay, that's the best way to think about it. Make it personal. Do you have a brother, Carolina?
Yeah.
Okay, good. I have 1 brother and 3 sisters. Okay, so also if you have problems understanding a question, if you think about it in dollars for whatever reason or prices, it's easier to understand. That's another trick, because I think numbers evolved for human use. And like the evolutionary background is for trade. Like, so I think when you start thinking about numbers in prices or in terms of cost, it always is easier to understand. Even though we have so many different examples, but if you try and think of it in dollars, it always seems easier. My dad also,
If they would give us more information, and for example, there were deaths or divorces, then that standard deviation would change.
yeah, people would
They would
drop
have to give us
of the
more
family.
information.
Exactly. Good question. Yeah. Exactly. You know, so they'd also have to say living family members or active family members, or yeah. It's too bad. All right, so let's go to number 22 for Victoria. I have the exam is in English and Spanish. There's just a few places where I don't put the Spanish, but it's when I use the terms of the course. So I just left it because I think the people who studied the Spanish notes still the terms are, you know, like outlier, response variable. I think the terms in English, if you have any problems, just ask me. There's like 2 problems where I never change the responses to be in Spanish, just because it seemed like confusing. just use the English terms that I taught. So every month for, oh, sorry, no, not this one. It was 22. Right? One student missed classes and received a fine. Oh, is this continued from somewhere? Yeah, okay. So let me bring this problem over here to the group. Like this is crooked. How do I make it? Doesn't want to go straight. Ah. It was pasted crooked. Anyway, we'll have to work with it. Do students who miss more classes get lower grades? Suppose that a random sample of 15 statistics students is selected and that the following output is obtained. So what do you see? Is there evidence there?
Yes.
Right. One student missed 2 classes and received a final exam score of 84. What is the value of the residual for this student? So we have a bunch of data here. If we want to look for if that person, so it should be in the scatter plot, right? So missed 2 classes. So this is 1, 2. This is 2.5, I guess. So this is supposed to be 2. So this, I think this is it here, and 84. So that's it there. So it's above the line. Observations above the line have positive or negative residuals.
Positive.
Right.
Positive.
Above the line are positive residuals, just the way we make the equation. The equation is that the residual for a certain observation is equal to, and everything is in the vertical, in alphabetical order, y observed minus y predicted. So it means that you have to identify the observed. They told you. So this is going to be the x. This is the y observed. And using the x, you have to find the y predicted. So they told you 84. So this is done. And then you got to get y predicted. How do we get y predicted or y hat? We use the equation. And the equation is here. Let's write it out. Y predicted is y hat equals 86.39 minus 2.64 times x. That's what x is. The class is missed. So you put the numbers in, 86.39 minus 2.64. The x is 2. And what do you get? Sorry for the slanted Tower of Pisa.
8111.
81.1.
81.11. Yeah.
It will keep 2 decimals. Okay, so that's the predicted value. So you put it here. And now you find out what you're finding is this distance here. Small, right?
Mm.
So what do you get?
2.89.
2.9.
So you see the answer now?
Yes. Thank you.
So the trick, did you pick D?
Yeah, I
You
got
could-
like a bit lost. So yeah, I selected the number D and I was like, why do I have it wrong? So it was in the calculations.
You didn't finish the question, but that's the thing. Yeah, you have to endure to answer the question. It feels like you did a lot because
Yeah.
you got an answer and it's there, but you're not finished. Now you use
Okay.
it and you put it here to get the residual. Yeah,
Well, thank you.
good. No, that's fine. That's a common mistake. That's why we have the question. So, all right, the next one. 611. Okay, didn't we do, what did we just do? We did 6. And 11. Oh, it's good. You guys are having the same problems. Okay, Aurora, is that okay? Because I just did 22.
Yeah, if we could do 11, that would be awesome.
Okay, we'll do 11. Aha, yeah. So this is another one. Once you learn how to do this, it's not so hard. Okay, so what you're going to do whenever you calculate a median is you rank the values, right? You put them in order. So we begin there, put them in order. The smallest one is 1, 2, 3. The next one is 1, 2, 7. The next one is 132. Next is 136. Then 138. And then 144. 151. And then 1, 2, 3 H's. I don't know what they are. Does it matter? Well, if we want the median, they're off on the, they're on the tail end. So it's okay. We don't need to know them. The median's closer, it's further away. But it's important to mark them so they have a place mark. And so out of 10, let's make sure I have them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I still use my rule that n plus 1 over 2 is where I'll find my median. So it's 11 over 2 or 5.5. So 1, 2, 3, 4, 5.5. So between these two. So which one is it? Is it one? It's 141. So now you average.
Yeah, 141. See.
Is that correct in the notes in the clave?
I think so.
So yeah, that's a good one to
See,
review because it's not at first what do you do with H, but it doesn't matter because they're not implicated here in the center. If there were, then you'd have something like that formula there. Well, not that one, but if you had an H here, you'd have to average with the H, but there is no H there.
Okay, thank you, Professor.
Okay, good. Okay, people are putting more and more and more. Okay. All right, so we have next, we're going to go to midterm 1. Okay, so it's nice, everyone. We did 2 first, now let's go to 1. 2 and 9. Oh, and somebody else sent me an email, I think. I have to see that. Let me see that email. Gabriel sent me an email about the Connect. Well, since that's your assignment, I'll just I'll have to answer him directly. I'll just answer him directly about it. And if it implicates you guys, I'll let you know. All right, so question number 2. The distribution of weekly salaries in a small company with 19 employees is such that the first quartile is that, the third quartile is that, and the range is that. Aha. Okay, so we're gonna go one at a time here and see which one is possible because it looks like a process of elimination type thing. So we have limited information. We just know the first quartile and the third quartile, and we know the range is 1,000. So we know that the maximum minus the minimum is 1,000. Do we know anything else? Do we know? Do we know the median? Can we know the median from this information?
No, because we don't have N.
We have N, we have 19, but we don't have
Then divided by.
we don't have the data, right? We don't have the data, but okay, so let's just focus on what we do have. We have that the range is 1,000. And what about the interquartile range? So you could
You have it. You have Q1 and Q3.
You just have Q1 and Q3. So that's how much? 600, right? Is the interquartile range. So there can be values. There are going to be values. There could be values lower than Q1. There can be values higher than Q3, right? Because this is only 600.
Yep. Or on the middle. Mhm.
In the middle, yeah, there can be values all spread out because this is just marking. This might not even be a value. This is just marking where 25% are below. This is marking where 75% are below. And there could be still more values up here. Well, there has to be either more values up here or more values down there, lower, because the range is 1,000. Its mean is 800. Its mean, see, I don't know what we don't know anything about the mean and standard deviation. So, okay, so you got to pick. So you don't know A through D. You just don't. How can you know the median? You can't. Like the median being 800 is possible, I guess. That's a possibility. It's not impossible.
You cannot double check because you don't have the data.
You cannot double check. So if you had to pick one of these, like your life depended on it, your job depended on it, which one would you pick?
The maximum between
E? Yeah.
E.
E.
E, right? Because this is going to be the Q3. And then, so like I said, either there's some values below or there's some values above, but between 1,100 and, some value larger, there could be a max, they could hit the largest value, the maximum. but I don't know what, but so this is the best answer. I know this is probably the most confusing for people who are just like trying to learn and like, how would you know that? Clearly, we don't know the median. We have no basis to calculate that because we don't have the data. We don't know anything about mean and standard deviation, so these are easily out. Just knowing these percentiles are not going to give us any information on mean and standard deviation, but this repeats sort of what I just said at the beginning, using this information, thinking, okay, well, this is only 600, so there can be values higher or there could be values lower. And then this satisfies the maximum could be 1100, but there could be something higher. I prefer if it's at 1100 or more as opposed to 1500. But the reason why they say 1500 is because it can't go higher than 1500 because it has to have a range of 1000. And the lower one, the smallest number could be 500 or could be smaller, but this is the highest, smallest number that we could have. So that's why they say 1500. So this is challenging. I don't think this is a good problem to have difficulty with. I hope I've resolved it. It's a good thinking exercise. But yeah, the whole test won't be thinking exercise like this.
Professor, in that case, if you have a problem like that, the calculations will be like just words, right? This cannot be possible because we don't have.
Yeah, you could just say, so the main thing here is, so given this information, so I wrote maximized minute is 1000. So there may be a minimum between so you can think about the most you can go even in the other direction, because if this was 600, so you can go 400 below, right, without violating. So if you make this your maximum, that's the smallest maximum you can have. Agreed? And then extend this direction back, so you can add 400 back, so that's 100. So this could be there's a minimum between 100 and 500. Or a maximum, I think, or a maximum between what they wrote, 1100 and 1500. That way, we maintain this range. So that's all you can get out of that information. Okay, let's see the next one. So think about that one. I'm going to go to 9, 9 and 10, and then 17. Same problems you guys are having. That's interesting. So 9, 10, and 17. And 19. And 18. So let me write that down. So 9, 10, 17, 18, 19. Okay. So I just translated from my words into some numbers here. That's all I did. Honoring the range.
So, Professor, I have a question. During the exam, we need to write the answer, like in Word, explain the results, or just the results
Just
in
usually numerical. It will be a numerical, but if you don't know what to write, just say something. Just write something to explain your choice. The main thing is that you have evidence for your thinking process, and then if there's any dispute, because we'll discuss the test after, you'll have your evidence already submitted to me, and I can look at it and say, oh yeah, she or he knew what they were doing. They were confused by the wording, or they were confused by so and so. I want you to write something. If someone just answers the exam, I should make it clear. You have to provide the written work, because otherwise I don't know. Unfortunately, the temptation is there to cheat and just someone, just writes down the answers. I need to see your written handwork, that it's your thinking that resolved the answer or resolved the question to get the answer. Okay, so you have to write something. All right, let's look at this one. This is another one, thinking one. All right, so let's see. I don't know if other people haven't had a chance to look at it, so I'll give you a moment to look at it. Again, we can use process of elimination.
Yeah, I believe by elimination, it's right to see why the others are not the correct one.
Yeah. So we have here, like continuous data, but then we have qualitative data here, like it's just grouped. So let's look, which ones would be these ones? Gender, right? Gender is categorical. And then handedness is categorical as well. So 1 and 3 is going to be these. And this is continuous. Heights and incomes are continuous. So those are going to be 2 and 4 are these ones. All right, so let's go with the first. The gender of a student in a class having somewhat more females than males recorded as 0 for males and 1 for female. With more females, no, I mean, so more females. So which one is it? This or this?
D.
Right. It's D. So 1 is D, because I can make a mark D.
Why?
So this is imagining that there's a number scale there. This is 0 and this is 1. And it says there's more females than males. So there's more females than males if you make 1 female. So I'm going with the information. So I can label it just so it's clear. So this is males marked as,
But
and this is.
I have some question because I don't have the names of the exes. Like I don't know what is the bars. I
Oh
don't
yeah,
know.
so it just remember that on a histogram,
Mhm.
it's always 0 to infinity, 0 to infinity, 0 to infinity. So this is 0. This is 1. Maybe it would be easier if they were beside each other. Otherwise it's so far away, but so this is marked as 0 and this is marked as 1. This higher number. So yeah, the axis is not there. So
Or
always on a
like-
histogram, the axis is always the measure. And this is the frequency. I made a video of this, right? So this is the variable X.
So maybe the categories are intense or something. And that's, if males have less than 10, it's 0, and if females have 10 or more, it's
No. No, this is just counting. Remember frequency. This is just the count, the number of. So this is counting. There's lots of females, little males. That's what this axis is here. Because these are the histograms. And histograms are either frequency or relative frequency. So I'll just do the counts, like the number of observations, I called it. So it's a good question. What is my axis? When it says histogram, you put the units on the horizontal and you put number of observations or percentage of observations on the vertical. It's very important. Does it make more sense now? So this is just counting. This is 10 men, this is 20 women.
Yeah, but my point is we don't have a scale. Like, how are we supposed to count?
You don't have a scale which way? On the X horizontal or on the vertical?
In both, I believe.
But this is more.
No,
That's
yeah,
how you know.
of
It
course,
just says
apparently
more. You
that,
don't need the numbers.
yeah, no, apparently that is more, but whatever. No, never mind.
No, it's okay. Let's keep going, because then you'll feel
Like,
better
I'm
better
trying to
when
explain
you
that.
finish. Yeah, so
we,
just remember this. Remember the
Mhm.
scale is on number of observations is here, and this is the variable. The
Mhm.
variable male, the variable called gender, has two outcomes, male or female.
Yeah, but my point is we don't have a scale. I mean, now it's more clear because males is 0, and even if, oh, yes and no, but even if you have 100 males, will be 0, but that's,
Yeah, this is counting, so this would say this is 100, and this
yeah, that,
200.
mhm. I mean, in that case, it's clear, but I believe my questions are on the A and B because, again, I don't have
Okay.
a scale, so it could be
Okay,
100 in my mind, and in the other person will be 500. So it's like abstract, like.
yeah, well, let's go to it. Let's go through all of them and clear it up. Okay, so then we're done with D. Now let's go to this one. The handedness of students in a class recorded as 0 for right hand and 1 for left hand. So this is gonna be right hand. This is left hand, and I know this is marked 0 and this one is 1, so it's higher up. And this is the number of observation, and more people are right-handed, right? That's why that works. I don't know if it's that small, but I don't know. I don't know the statistics on handedness. My husband is left-handed. So we've done, so that's C. Okay, so now we've broken it down. Now we're at, let's do number 2. So this for number 2 and number 4, this goes back to the first class I discussed shapes of distributions. And yeah, it's abstract in this sense that how do I know? I don't have any scale here, but in general, incomes I mentioned are right skewed. There's a few people that make a lot of money. So that's something you need to take to the table here, that you knew that. So incomes for lawyers, for general population, for women, for men, always right skewed because of that 1%, those few people that make a lot of money. So these are the lawyers, corporate lawyers, medical lawyers make a lot of money over here. And in general, grades or heights or weights are roughly symmetric and they look like this. So that's how I know that this one is A and this one is B. So you have to have prior information. And the main thing being that, so this one would just be as a process of elimination, that this one would be the heights of certain students in class, because you should know that incomes are right skewed. And this one makes sense once you spell it out. So B ends up being the height of students in a certain class as a default. So my answer, okay, wait, I do this backwards. So one is, let's see what happened here. Oh, so
B.
A through D. So then it's going to be, I guess I have to do it this way. So A I said is 4. And B I said was 2. And C I said was 3. And D I said was 1. So it's 4, 2, 3, 1. So I agree with you. It feels like, how would I know that? But this depends on remembering about incomes being right skewed. So you're right. Does depend on some special knowledge.
So my question is if in the exam I have an exercises like this one, right? And I put instead the A be the 4 and the B be the second one. If I put it like A the 2 and B the 4th, it could be wrong, but it could be right because
It could be right.
like that's my point. Like it's too abstract. Like it could be right or not because you don't have a skill, you don't have X's name, you don't have nothing that mentioned that.
Well, I'm pretty sure that lawyers have this income scale, but you're right. If they were in a group in a legal firm and they all
it could be variable. I mean,
projects, they all made fair. Yeah, sure.
The CEO could be the higher one, and the lawyer, it's a freshman, could be the I mean, vice versa,
Yeah,
but
no,
whatever.
you're right. You're right. But you're thinking, the best answer, like like in this case, this one will help differentiate between the two. You could argue this better, that, yeah, there's a few. And you can say, in the class when we learned graphing and distributions, you said, so yeah, you could defend yourself that way. But yeah, you make a point. You make a point, it's true. How do I know? All right, next one is 10. So this one I have in the notes, right? I have a similar problem. How do we solve this? Actually, no, I do it with the mean, but how do we do the median? So let's find out how many observations there are, how many students are there. That's where we start with the median. We always have to know n. So what is n?
Nine.
How much?
9.
9.
No.
No,
No, that's wrong. Sorry.
Yeah, no, it's okay, because that's exactly the point. It's you have to learn this. Okay, so you counted 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are the different, no. They're grouped. We grouped the observations together. So there's 14 that have an age of 18. There's 120 with an age of 19. There's 200 with an age of 20. So I'm pretty sure I review this in the notes. Go back and see. But I think I did it with mean as opposed to median. But yeah, so that's maybe why you have to rework your brain. This is for median. So I need to know the n. The n is going to be summing all of these up. So the total,
according to
600,
it's
967.
667.
667, good. So there you go. Now you do n plus 1 over 2, which is 668 divided by 2, which is 334. Now, find the marking, the position of 334. Where is it going to be? Somewhere around here. So where will the 334th observation be?
Right in the 20?
So yeah, because so if you want, you can do a cumulative. So you can cumulative, so to here is 14, to here is 134. And then you keep adding, this will be 334. You see what I'm doing? I'm just saying up until 18, you have 14 observation, and the 19th, now you have another 120, so it's 134 observations. And then if I add to 200, that's 334. So what is my 334th observation?
20?
20. Yeah, so it wasn't that bad. If I want the 335th observation, what is the answer?
21.
It would be over here. Yeah, so they're it's to simplify the data because they all fell into groups, and it's another way that data can be presented. This would actually be the structure. This is how you make the histogram, right? Counting how many observations in each group, but this is actually the values as opposed to classes, because it's discrete data. Now, age doesn't have to be discrete. Age can be continuous, but they're reporting it as whole numbers. So the answer is 20, should be 20. Questions about that? Anyone want me to repeat? 10. Okay, so we are on to 17. Do you want a break, or do you want to just me to continue? Do you want a break?
We have a 5-minute break.
Yeah, let's have a break, and then we'll do 17, 18, 19. So yeah, let's meet back here at 11. Okay, I'm back. All right, so we continue with 17. Okay, so treat this one here. 17 says to find B. So this is just like, don't let them confuse you. It's just like this. And this means to us, remember, in between, right? In between. So in between, how do I get 0.8 or 80%? So that's not a standard number I know. We know 68, 95, 99.7, correct? But now they're saying 0.8. So what do? I'm going to I'm going to draw it for myself. And I know that between here and here is 80%. If it's 80% in between, then it's 20% outside, or 10% on both sides. I'm going to the left side because the tables are always in the left. So I'm going to look up 10% to find the negative Z or the negative B. Okay, so look on the table to find 10%. So this should feel familiar. We did this from the beginning with normal. But anyway, I'm using 80% now.
It's point it's 0.221. Oh. Oh no, it's the other one. Mm-hmm.
1.28.
I So, Professor. I got the right answer, Professor, but I was only searching for 0.1, the closest to 0.1, which was negative 128. And it doesn't matter if it's negative or positive. But
Professor, I believe you're mute.
I don't know why I turned that off. Okay. So it's 10%. You look it up inside the table on the left because the data, sorry, Excel and the tables only give you the left. So you look up 10 and that's the closest. When you look on the margin, you find negative 1.28. Where did you go wrong, Christina?
no, I got it.
Okay, good.
But I went 1 minus 0.8 and then it's the same, don't worry.
Right, you got it, but you didn't stop. You kept going. Okay. Okay, 17, 18. An instructor from the statistics department gives a 100-point exam for which the scores are approximately normally distributed with a mean of 70 and standard deviation of 10. What is the minimum mark that a student needs to achieve in order to obtain an A+? So we did this last class. We did a problem like this. If 10% of the students will receive an A+.
It's the percentile, right?
It's a backward problem because I give you the percentage and you have to give me the score. So I want 10% to be getting the A+, So this is 10% here. So then on the left side, how much do I have?
90%.
I have 90%, or I write that as 0. I'm gonna have to use a different color. 0.9000. So I used 4 decimals just to remind you to go inside the table, right? So that's it. You're going to find out through 2 steps. You're going to first find the position in number of standard deviations from the mean that you find the value you find here with 90% of the standard, 90% of the observations to the left. So what would that Z be?
1.28.
Right, it's like the other problem. 1.28, exactly. Because it was 10% at negative 1.28. 10% above is also at 1.28, but the positive 1.28. And then what do? Are we finished? No, now we have to convert that into the problem at hand. So we're going to convert it. X equals Z standard deviations from the mean, and we plug the values in. Z is 1.28. We're told that the standard deviation for these grades are 10 plus a mean of 70. Oh, my table. All my graphs are crooked. And what
82, 82.8.
why 30? What did you say?
Letter E.
82.8, yeah. I only have one more to do, and that's question 19. So try that one.
Oh.
C.
So I believe the A is 95.
Sorry again?
I'm not sure. I mean, that's the 19, right?
19.
Yeah, that was my question. I'm not sure which is the A, if the A or the or yeah, if A or B. Or B? Yeah.
Okay, well, first of all, this one is negative sloping, this one is positive sloping, and this one is pretty flat.
Mm-hmm.
Maybe a little bit positive. So when you look at this, you're supposed to look to see the trend.
Mm-hmm.
And as I explained before, the slope and the correlation have the same sign. So you can look at it visually as a slope. So this one has a negative slope. This one has a positive slope. This one has a flat. If it's
So
flat,
For
It's
me,
to
it's the
zero.
answer C.
So this one would be negative,
Mhm,
one would be positive, and this one would be close to 0.
mhm.
C is the best answer. Anybody pick another one? Yeah, you guys all got C. Okay, so that one's not too tough. So if you watch all my videos, this is gonna be easy because I talk about this. I draw these and I discuss them from the start. So if you have gaps, gotta go back page by page, see where you have the gap and rewatch. Are there any other questions? You guys can contact me during the test if you have questions about the test. I'm not gonna post it till 1. You guys can continue to study. Let me know if you have any comments or questions about how to prepare your documents. I have a link where you can upload a PDF single file of your written work. I don't want you to submit 200 pages, just one document, all as one. And that's, like I've said, that's the evidence you provide, and you have to provide it. You can't just answer this multiple choice you can't just pick problems and submit that. That's not you'll get 0. You'll get 0. So you can be in touch. If you have any questions about the material, you have a couple of hours to contact me. After that, I cannot answer any questions. But you have in virtual mode, you have me online. You can watch the videos. I'm not going to block the platform or anything.
Oh, sorry.
Go ahead, Mari. No?
Okay, the test will be through Moodle, right?
Yeah, it's going to be right at the top of the platform.
Okay, thank you.
And it will be multiple choice, but it will also have so you answer the questions in the multiple choice link, but then you submit your responses, like the handwritten responses, solutions in a different link below.
Okay, thank you.
Can I print it out? And then
You're gonna write it out. You're gonna don't use Word or anything like that. You can use Excel, but then you're gonna submit your handwritten work. And sorry, there's distraction on the street right now. Hold on. Let me put the volume down for a second. All right, so yeah, so you're going to combine them into a single PDF with a scanner or with your phone, put all the documents in one PDF document to upload.
Maximum 2 pages or something like that?
Oh, no, one document, but you can have as many pages as you want. Okay.
No, oh yeah, that's my question.
Yeah. Christina, you had a question still?
yes, I guess I'm old school. I like to print it out and write on it. I was wondering if we would be able to print it out before answering on the Moodle.
Absolutely.
So we can print
You can print it and you can write on the paper if you want. But no, it doesn't have sorry, it's not going to be paper. What am I saying? It's all going to be in the platform. But you can print the screen and print them. You can print the pages. There are 5 questions from each module. So yeah, you can print them. You can print them out and answer them, and you can submit it like that, Christina. That's fine.
Okay. Professor, but
that's better
to be able to do that, you have to screenshot, right?
Yeah, you can screenshot. Yeah, you'll screenshot.
Thank you.
Yeah.
we will have a time limit or something?
You have 3 days. And you go
Yeah.
in and you can go out. There's no limit. I'm not going to put any restriction. Like the quizzes that I put on the platform in Moodle, those have a limit just to give you an idea. You know, you're slow, you're fast, but there's no time limit on the exam. It's just for feedback for you. Victoria, she's been patiently waiting with her hand.
Hi. So the question is like when we have to upload the document, it's gonna be like later on the space where the exam is posted.
Yeah, it's right below. Yeah.
Okay.
Yeah.
And it's gonna be on top of the Moodle part of the class?
Yeah, it'll be at the top of the page. Yeah.
Okay, perfect. Thank you.
Sure. I know so many unknowns. All
So,
right.
Professor, to be sure, it will be due to 1 p.m. on Monday, right?
You know what? No, 3 days, Saturday, Sunday, Sunday to Monday, Monday to Tuesday. I'm leaving it till 11:59 p.m. on Tuesday night,
Okay, perfect. Thank
more
you.
than 3 days. Because some people work, they have not, there's no way they can do anything in the day, so. All right, so I'll post this video up so you can review it if you want to go back. And other than that, I will post a regression assignment for Connect for the next week. So I will post it after the exam, like on Tuesday, Wednesday, yeah. And then when we meet next week, we will be talking about probability. So you're going to finish this test as soon as possible, efficiently, and get started on probabilities. So next week, we're going to talk about probability, which is module.
The next exam is going to be, hi, if the next exam is going to be only probability or it's going to be all the material?
Oh, well, there's 3 more. We're going to do, there's going to be 3 more modules, 4, 6, 7, 8, and 9 modules. And it will be cumulative exam, but I have a description in module 9 that describes what the exam consists of. It's mostly the last module. It's 40% on inference, the last module, but you'll see that everything builds to inference. So I'm testing everything in the context of inference. So you'll see it, this material that we finish is only going to be 10% of the final exam. But if you don't know normal distributions, you can't do inference. So you have to know everything. It's just, I'm not going to directly test this material again. Not in great quantity, like I said, 10% of the final.
Okay. When you talked in the beginning about optimization theory, that's exactly what?
You mean about regression with optimization? It's calculus. It uses calculus to find a minimum value or a maximum value. In the case of regression, you want to minimize the sum of the squared residuals. I explain it in the videos that we want to minimize the residuals, the value between the predicted line and the observed values. Okay. So to do that is it's a calculus that results in a pattern that gives us that slope equation. But I don't want to talk too much about it because it's outside the scope of the class, and it's tough, you know. My training is my core training is my first degree was statistics, and so that's how I learned it, but I can't get into that here because it's, again, calculus was not
okay.
And I keep getting told not to talk about calculus. So yeah, but that's where it comes from. Thank you. Thanks for the question, Elizabeth. All right, so ready? You have an hour and a half. I'm going to open it. You'll be fine, Vanessa. You're good. Are there any other questions? Any other problems?
Just stress.
Oh, just breathe. I give you so many.
Yeah.
Just, yeah, hopefully you can take today in silence and nobody's working. And tomorrow, and then the week starts. So do your bulk of the work. I would suggest just get into the exam and start solving the problems, and then you have a few days to think about it, you know, and see where your gaps are in understanding. That's what I recommend. Just try the most of it, and then you can feel confident, and then maybe there's still going to be a few problems you cannot solve, but if you got the bulk of them, you should be fine. Okay? You're going to be fine.
We hope so.
People do fine in this class, really. Just if you do the work, it's a lot of work, and that's where the trouble is, just getting through the material. But otherwise, in brain power, you don't have to be a genius, so don't worry. I'm not a genius.
Professor, for the next week, we have the other class too, and I know it's like a little bit heavier model. Do you need to discuss it longer, or it's just to prepare?
So the other class starts at what time? 11:30?
She's gonna start at 12, right?
Yeah, I think it's 12.
So we can go till 11. We can go a little bit more if you feel, Maria, that we need more time. We can go to 11:45. I just need to leave a break so people can relax and get organized.
That's okay.
And lunch.
Thank you.
Eat something, yeah. Well, yeah, absolutely. I get it. It's true. You have to eat. We'll see, because in fact, probability is mostly very intuitive. I just clarify some concepts. Let me look at the platform for a moment. Victoria, you have another question?
Yes, I was seeing the module for next week. We only have to watch like conference number 1, right? Or we have to
3
watch.
hours.
Yeah.
Let me see, what did I do here? Okay, hold on, let me watch what I did. See how far I got. What I'll do is I'll make a note.
Okay.
So conference number 1 is 3 hours. That's quite long. And then, which is, I think, going to cover most of it. And then I'll look in the other ones to see if there's any supplemental you should watch. But yeah, get through the 3 hours, and then
Okay.
I'll see if I can recommend out of the others what's important.
Okay, thank you.
But you have lots of problems to solve. But I think the bulk of it is that 3-hour competencia from last semester.
Okay, thanks.
Sure. There's no page by page. I didn't do too much page by page. There's just a few. Sorry.
Professor, the exam will be available today at 1 p.m., right?
Correct. So you can text me. How many questions? Did I already answer that? Yeah, it was 5 from each, from module 2, 3, 4, and 5, and yeah. So 5 from each should be 20. I don't know why I'm doubting. I reviewed it just now, but I think, yeah, it's 5 from each. So text me if you have any questions. If you can't enter, anything's happening. No more problems for me? You want me to stay here another hour? I just don't want to give too much material on here that people have to review later. They're gonna feel like they missed something. Nothing pressing? Well, just continue and I'll be available the next hour if you have any questions or you want to meet, hour and a half. Okay?
Thank you.
Okay, and text me if you have questions in the next hour and a half. After that, I cannot answer anything direct unless it's some like typo or error or something you found in the notes or in the exam. So thank you for your attendance. Just breathe, relax, put some soft music on, whatever makes you relax, and you're gonna be fine. You worked very hard to be here, so you're gonna be just fine. I know it. Okay, so we'll talk soon. Keep in touch.
Thank you.
Okay, have
Thank
a
you.
good
Thank you. Have an
Thank
excellent
you.
day.
Thank you. Have a good one.
Good luck, everyone.
Good luck.
Good luck.
Bye.
Bye.